Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
LCM. Well, let's think about the HCF and LCM. Okay, so HCF is the highest common factor. Okay, so this is if I had to list all of the factors in a line or in consecutive order of two numbers. I would then circle the biggest one that I've listed. So for example, let's look at the HCF of, let's look at the HCF of, for example, 60 and 80. Okay, how are we going to do this? Well, firstly, we're going to have to list the factors of 60. Well, what are the factors of 60? Okay, I know that the factors of 60 are always going to be 1 in itself. Okay, you can list them in consecutive order like this, or you can list them next to one another as long as you note that they won't be in consecutive order if you just list them in pairs. Okay, so 1 and 60. What else goes into 60? Well, 2 goes into 60. How many times? 30 times. Does 3 go into 60? Yes. 3 goes into 60 20 times. Does 4 go into 60? Let's see. Yes, it goes in 15 times. Okay. Does 5 go into 60? Yes, it ends in 0, so 5 will go into 60. And it goes in 12 times. Okay, 6 goes into 60 10 times. Does 7 go into 60? No. 8? No. And so here I am done. So these are the factors of 60. Okay, so let's look at the factors. Let's look at the factors of 80. Okay, so again, I'm going to start with 1 and 80. Okay, what else goes into 80? Well, 2 goes in 40 times. I just list them this way so they come up in a consecutive order. Does 3 go into 80? No, it doesn't. 4 will go into 80 20 times. Okay. 5, does 5 go into 80? Yes, it will. How many times? Will go in 16 times. Okay, does 6 go into 80? Nope. 7. Nope. 8 will go in 10 times. Okay. Will 9 go in? No. 10 will go in, and there we are. There we're done. Okay. So to find the highest common factor, I will need to then circle the highest number that exists in both. And so I can see for this one, the highest common factor will be 20. Okay. And so to find the highest common factor, I can either list all the factors and then circle, or I can use prime factorization. So we need to understand that prime factorization is going to be simpler, because what if we get a number that's huge? What if we get a number that's massive and we're going to spend all this time working on a calculator to find the highest common factor of each? Okay, what is the lowest common multiple then? The lowest common multiple, we know that a multiple, it's kind of like the times tables. right? So if I had to write the multiples of 60, I would say, okay, 60, then 120, oops, 120, what's next? 180, 240, 300. Okay, so these are the first 5 multiples of 60. So if I wanted to find the lowest common multiple, I would do the same for 80 and see which one comes first. So the highest common factor is the biggest number that you can see that is the same, and the lowest common multiple is the first number which you can see is the same. Okay, so the multiples of 80 would be 80, 160, 240, and here we can see these two match up, and so the LCM would be 240. So we can say for 60 and 80, the HCF is 20, and the LCM is 240. Okay, so that is how we find HCF and LCM using lists. Okay, but we don't always want to use lists, right? Sometimes we can do HCF and LCM using prime factorization, or always we can do HCF and LCM using prime factorization. And in fact, it actually is easier. So let's have a look at 60 and 80 using prime factorization. Now we know how to do prime factorization at this point. Okay, so the first thing we're going to do is we're going to divide by our first prime number, which is 2, and that goes in 30 times. 2 again, 15 times. Then we're going to go 3, 5 times, and 5 once. And so 60 is equal to 2 squared times 3 times 5. Okay. What about 80? Let's look at 80. Well, let's see again. It's even, so 2 can go in. 2 is going to go in 40 times, and then 2 again, 20 times, 2 again, 10 times, 2. And then get a 5 and 5 and 1. And so if I want to write 80, I'm going to say 2 to the power of 4 times 5. Okay, so if I want to find the HCF, all I'm going to do is I'm going to circle the ones that are common in each. So I'm going to say, okay, this 2 matches up with this 2 matches up with this 2, and then I just have 1 5 that matches up. And so I can say, okay, what's common? Well, what's common is a 2, another 2, and a 5. And so 2 times 2 times 5 is 20. Okay, and this will work for any 2 numbers. So this is HCF using prime factorization. So we just do the prime factor ladders of each and match up what is common in each, multiplying them together. That is the HCF. So the highest common factor, what is common in each, multiplied together. Okay, so here I know that my HCF is equal to 20. Okay, how do I then find my LCM? Well, what's important here is to know that in order to find my LCM, I have to already know my HCF. So I have to have already done my prime factor ladders and circled what is common for H. Oops, sorry. Okay, so in this case, what's common is a 2, and a 5. That's my HCF. So to find LCM, all I do is I go back to my prime factor ladder. Let me pick a green one. I am then going to pick out what I left out. And I'm going to multiply what I left out to my HCF. So the LCM is going to be equal to the original HCF, which is 20, and I'm going to times 3, 2, and 2. And if I do this, I'm going to see that 20 times 3 times 2 times 2 is, voila, 240. Amazing. Okay, so this is how I do HCF and LCM. Okay, so let's do a couple of examples using this idea. Okay, firstly, I want to write 45 as a product of its prime factors. Well, we know that when we do a prime factors and product, we have to use a prime factor ladder. Okay, so that's what I'm going to do. I'm going to take my 45 and I'm going to start doing a prime factor ladder. Well, because 45 is odd, I know that 2 will not go into 45. Will 3 go into 45? Well, in the last lesson, we looked at how to know if something is divisible by 3. And to do this, we are going to add the digits together. 4 plus 5 is 9. Is 9 divisible by 3? Yes. And so 45 is divisible by 3. Okay. 45 divided by 3 is 15. Cool. Is 15 divisible by 2? No, 2 is even. It is divisible by 3, divisible by 3 5 times, and 5 is divisible by 5 once. And so that I can say that 45 is equal to 3 squared times 5, and there I will get all of my marks. Okay, next question. Find the highest common factor of 45 and 105. Okay, so 45 we already know it goes 3, 3, and 5. So 3 times 3 times 5 is 45. Let's do 105. Remember, you always have to do both to find an HCF. Okay, let's do 105. Okay, is 105 divisible by 3? Oops. Sorry, I just want to erase this. Carry on in green, may as well. Okay, is 105 divisible by 3? Well, 1 plus 5 is 6, and 6 is divisible by 3, so 105 will be divisible by 3, and 105 divided by 3 is 35. Okay, is 35 divisible by 3? No, because 3 plus 5 is 8, so I'm going to go with 5 being the first prime factor I can divide in. Yeah. 35 divided by 5 is 7. And 7 can be divided by itself once. And so I can write 105 as 3 times 5 times 7. Well, then what is my HCF? I am going to circle the ones that are common. What's common? There's a common 3, and there's a common 5. And so the HCF is going to be equal to 3 times 5, which is 15. And so I'm going to just put my final answer here. Okay. Next one. Find the lowest common multiple of 36 and 48. Well, for lowest common multiple, I know that I need to first find the HCF by building a prime factor ladder, right? And then after that, circling what's left over to find LCM. Okay, so let's find HCF first. Let's do the prime factor ladder of 36. Oops. It's a bit untidy. Okay, let's do 36. All right, what goes into 36 first? It's even, so I'm going to divide in at 2. 36 divided by 2 is 18. This can also be divided by 2. 18 divided by 2 is 9, which is divisible by 3. And 3, which is divisible by 3 and gives you 1. So I know that 36, if I had to write 36 as a product of its prime factors, 36 would be equal to 2 squared times 3 squared. Okay, next let's do 48. Okay, and then what are the factors of 48? Well, the first one's going to be 2 because it's even. 48 is divisible by 2 24 times. 2 again is going to give me 12. 2 again is going to give me 6, which is also divisible by 2 3 times, and 3 is divisible by 3 once. Okay, and so if I had to write 48 as a product of its prime factors, it would be equal to 2 to the power of 4 times 3. And so what is common here? Well, what's common, back on my green, what's common here is 2's, 2 of them, and 1 3. So I'm going to say my HCF is equal to 2 squared times 3, which is 12. So my highest common factor is 12. For LCM, I'm then going to take my highest common factor and multiply it by what was left over in my ladders. And that, just use a blue or use something a bit darker, the purple, is going to be this 3 over here, this 2 over here, and this 2 over here. And so I'm going to say 12 times 3 times 2 times 2. And so then my LCM, 12 times 3 times 2 times 2, is 144. And I'm going to put it on my final answer line. Okay. All right. Again, let's write 60 as a product of its prime factors very quickly and very easily. We know how to do this now. And divide by 2 30 times, and 2 15 times, and 3 5 times, and 5 once. And so I'm going to say 60 is equal to 2 squared times 3 times 5. All right. Okay, some more practice. 36 and 60, we've already said that 60 is 2 squared times 3 times 5. Okay, we've said that 36 is what? Let's go back and look. 36 is 2 squared times 3 squared. Okay, now let's have a look at this. If we have already been given our prime factorization, let's see if we can find LCM now. Well, the first step in finding LCM we know is to find HCF. So what is going to be common in these factors? Well, the 2 squareds are common and one of the 3's is common. And so I will know that HCF is equal to 2 squared times 3, which is 12. Okay, so now I've got my HCF. My LCM is then going to be 12 times what was left over. Okay, and what was left over? Let's see. Well, we've already discarded these. We've already used them. We've used 1 3, so I can just cross out the square. There's only 1 3 that I've used. And so what's left over is the 3 and the 5. And so LCM is going to be our HCF of 12 times 5 times 3, which is 180. Great. Okay. Okay. So there is a way, now that we understand prime factor ladders and we understand prime factorization and how they're important for HCF and LCM, there is a way to use our calculator for prime factorization. And we can do this, but only when the question says to write down the prime factors or to write something in terms of the product of its prime factors, not when it says calculate. Okay, so this is very important. We can use our calculator trick, but only when we have a write down command. And when our marks are very low, like for example 1 or 2 marks, not 4 or 5 marks. And this is very important. Okay, so how do we do this? Well, let's practice together. Pick up your calculator. I want to write 160 as a product of its prime factors. So the first thing I'm going to do is I'm going to type 160 in my calculator and press equal so that I can see it on the bottom of my screen. So over here. So I press my 160 in and then I can see it on the bottom appearing. I then press shift. On the top left-hand corner, I see a little yellow button called shift. I press shift and then I press fact. You'll see it's got all sort of dots and commas on it. Also on the left-hand side, I press fact and then I will see appearing on my calculator 160 written as a product of its prime factors. And there I can see if I compared it to a prime factor ladder, right, let's see, 160 divided by 2 is 80, divided by 2 is 40, divided by 2 is 20, 2 is 10, 2 is 5, and 5 and 1. And so I will be able to see that 160 is going to be 2 to the 5 times 5. Okay, so it's important that we know how to do this. We will be able to save a lot of time in our exam, but just to note that we must only use it when it says write down. Okay, so let's have a quick look at knowing how to do a LCM and HCF when we have calculated something on our calculator. And I'm just going to erase this. Okay, so if I had to do this on my calculator, I would very quickly put the 36 and 60 on my calculator. So I would say 36 equals, I would type 36 into my calculator, press equals, then press shift fact, and I would say, okay, 36 is 2 squared times 3 squared. Okay, same with 60. I'm going to press 60 on my calculator, press equals, press shift fact, and be able to see it as it is given to me. All right. So now I know exactly how to do prime factorization, I know how to do HCF and LCM, and I know how to do prime factorizations on my calculator. But what's more important here is understanding how else prime factorizations can work. Well, prime factorizations can also give us roots. I'm just going to stick it over here. Okay, and just very quickly, I can use prime factorization to find any root of any number. So for example, if I wanted to find the square root of 144, what I could do is I could do a prime factorization of this number and then circle the answers in pairs. So let's have a quick look. Let's do the prime factor ladder for 144. 2 goes into 144 72 times. And 2 goes into 72 36 times. And 2 goes into 36 18 times. 2 goes into 18 9 times. And 3 goes into 9 3 times. And 1. Okay, so if I wanted to find the square root, square meaning the second root of 144, all I would go do is circle these in pairs. 1, 2, 3 pairs. And so I've got a pair of 2s. I've got a pair of another 2. And I've got a pair of 3s. And so the square root or the second root of 144 is 2 times 2 times 3, which is 12. And this we know. We know for a fact that the square root of 144 is 12. What if I wanted to find the cube root? Okay, what if I wanted to find the cube root? Let's say I wanted to find the cube root, for example, of a big number. Let's try a huge number, 1728. Now, don't let this intimidate you, the fact that it's big. Firstly, we can do this factorization on our calculator if we wanted to. And secondly, because we know prime factorization, we don't need to be afraid of looking at roots of big numbers or big roots of small numbers, etc. So we could find the 5th root of a number, we could find the 10th root of a number, all by just circling things in groups. Okay, so let's try and find the prime factorized version of 1728. Well, divided by 2, we can see it's divisible by 2 because it's even, and that gives me 864. I can divide that by 2, and that's going to give me 432. Dividing that by 2, I get 216. Dividing that by 2, I get 108. Okay, 2 again is going to give me 54. 2 again is going to give me 27. Yeah, I can't divide by 2. I'm going to divide by 3. 27 divided by 3 is 9. And I've got my 2 3s again and 1. Okay, so if I want the 3rd root of 1728, all I'm going to do is I'm going to group in 3s. And this is why I list my prime factors from smaller so I can group them all together. And so I can see that the cube root of 1728 has one group of 2's here, another group of 2's, and a group of 3's. And so the cube root of 1728 is 12, which you can check on your calculator. Okay, great. So, just to sum up today, we have had a look at all sorts of things. We've looked at prime factorization and understanding prime factor ladders, how we find HCF from them, LCM as well, using a calculator to find prime factors, and understanding prime factorization in terms of roots. So thank you for joining me today. I hope you have a wonderful, wonderful weekend. And I implore you to keep working hard, keep submitting your assignments every week so I can give you some feedback, and have a great day.
Saying things that degrade women, for me, number one, I am not there, because that is basically what I don't believe in. I don't stand for things that degrade women.
What do you think we can add? What can we put in the basket? First of all, let's put Blossom back in the basket.
Look at the person like, man, let's do a song.
Let's do something.
Just
let's
like
collaborate.
Let's collaborate.
The Africans were claiming us.
Yes, exactly. To the rest of the world, they belong to us. Namibia, Baba, Namibia.
I'll help you carry on.
Creating music and putting some stuff out for the people who've been supporting me, that's definitely something that's next on my list.